Hello there, welcome to Excellent Scholars Academy, and in today's video I'm going to be introducing to you integration. I'm going to give you all the basic principles you need to know about integration so you can solve any problem and have a very good foundation on integration. Okay, so now let's look at this. Now, if you have an integral of x to the power of n with respect to dx, you want to integrate this. Now, what is going to happen is I am going to add 1 to the power of n over the same addition of the power plus a constant of integration. Now, we always add a constant of integration after integrating a function because we assume that there was something that was differentiated when it was differentiated. Now, don't forget, integration is the opposite of differentiation, and differentiation is the opposite of integration. Don't forget. So sometimes integration is also called antiderivative. Just like you have malaria and then you have anti-malaria. So my African people would try to understand what I'm trying to say. Okay, so when we add a constant of integration, we are assuming that there was something that was differentiated. So now that we are integrating what was differentiated, we add a constant of integration, which some people call arbitrary constant. Okay, I hope you understand that. So we want to integrate this function. You're going to add 1 to the power over the same addition of the power, that's n plus 1, plus your constant of integration. So for instance, if you want to integrate x squared with respect to dx, want to integrate x squared with respect to dx, all you need to do is add 1 to the power here over the same 2 plus 1 plus your constant of integration. So 2 plus 1 gives us 3, so that's x to the power of 3 over 3. Okay, now let's try another one. You want to integrate now. Oh, I forgot to tell you. If you want to integrate something like this, you want to integrate dx. If you integrate dx, it's like the integral takes away the d, and then you are going to have x plus your constant of integration. So another thing you need to note is if you integrate dx, you're going to get x. Now let's try integrating something else. Now I want to integrate 2x with respect to dx. I want to integrate 2x with respect to dx. Now 2 here is a constant, so make sure you pull it out. Every time you want to integrate, try to pull out every constant before you integrate. Okay, so now the constant here is 2. You bring it out, it's going to be 2 integral of x dx. Okay, now there's an invisible 1 on x here, so this becomes 2 times, we are going to integrate this now, so integrating x with respect to dx becomes x to the power of 1 plus 1, because like I said, there's an invisible 1 here, over the same 1 plus 1 plus your constant of integration. So this becomes, now it becomes 2 times x to the power of 2 over 2. Now, plus your constant of integration. Now you can clearly see that these 2 can take away these 2, and then it becomes x squared plus c. So the integration of 2x gives us x squared. Coming back here, the integration of x squared gives us x to the power of 3 over 3. The integration of dx gives us x plus our constant, and then the integration of 2x gives us x squared plus c. Now, so these are the basic things you need to know. Now, I'll be giving you basic formulas on integration because many students often forget these principles and these formulas. That's why they find themselves not being able to solve some questions or some problems they encounter when they're dealing with integration questions or questions on integration. So I'm going to be giving you the basic principles you need to know. Okay, so now we're going to be looking at basic principles, like I said, basic integration formulas that you need to know. So the first one we'll look at is, if you have an integration of a function x to the power of n with respect to dx, all you need to do is add 1 to the power over the same n plus 1 plus a constant of integration. Now, the next one we're going to look at is, if you have a function, a trigonometric function sine x, you integrate sine x with respect to dx. Now, if you integrate sine x, you are going to get minus cos x plus your constant of integration. Now, do not forget that when you differentiate cos x, you get minus sin x. So now that you are integrating sin x, you are going to have minus cos x. So let's look at the next one. If you integrate cos x dx, you are going to have sin x plus a constant of integration. You integrate this, you're going to have this. Okay? Now, look at, if you differentiate sin x, you're going to have cos x. But now, integrating cos x, you're going to have sin x. So now, the next one we're going to look at is, if you have integral of an exponential function, exponential x, with respect to dx. Now, when you integrate an exponential function as this, you are still going to have exponential x plus c. You're still going to have this as your integral. Now, okay, so now the next one we're going to look at will be sec square x. If you integrate a function sec square x with respect to dx, you are going to have tan x plus c. You're going to have tan x plus c. Don't forget too that if you differentiate tan x, you are going to get sec square x. So now, if you are integrating sec square x, you're going to have tan x because you are going back. You are doing an antiderivative. Okay, I hope you understand that. So now the next one we're going to be looking at is cosec square x. Now, if you integrate cosec square x with respect to dx, you are going to have minus cot x plus your constant of integration. If you integrate cosec square x, you're going to have minus cot x plus your constant of integration. Okay, so the next one we're going to look at will be sec x tan x. If you integrate sec x tan x with respect to dx, you are going to have sec x. You integrate sec x tan x with respect to dx, you are going to have sec x. Okay, now the next one we're going to look at now will be integral of cosec x cot x. Now, with respect to dx. Now, if we integrate this cosec x and cot x with respect to dx, we're going to have minus cosec x plus a constant of integration. We integrate cosec x cot x with respect to dx, we're going to have minus cosec x plus our constant of integration. If you have the integral of a to the power of x ln a with respect to dx, you are going to have your integral to be a to the power of x plus your constant of integration. Because if you differentiate this, you are going to have this. So now, integrating this, you are going to have this. So the next one we're going to look at will be, if you integrate tan x with respect to dx, you are going to have your answer to be log sec x base e plus your constant of integration. If you integrate tan x with respect to dx, you're going to have this. Or you could also write this as ln sec x plus c. Log base e and ln are actually the same. So you could also write this like this or like this. So now the next one we're going to look at is, if you have an integral of cot x with respect to dx, you are going to have your integral to be log sine x base e. Or from here, you could also write it as or ln sine x. So any of this is the integral of this function. Okay, so now let's look at the next one. If you have an integral of 1 over a squared plus x squared with respect to dx, your integral is going to be 1 over a tan inverse of x over a plus your constant of integration. If you have this kind of function, you integrate if an integral of this form, 1 over a squared plus x squared with respect to dx, you're going to have 1 over a tan inverse of x over a plus c. Okay, now another one we'll look at is this. If you have an integral of square root of a squared minus x squared with respect to dx. You're going to have your integral to be a squared over 2 sine inverse of x over a plus c. You have an integral of this form, square root of a squared minus x squared with respect to dx. You're going to have your integral to be a squared over 2 sine inverse of x over a. Okay? Now, we're going to be looking at more. If you have an integral of this form, integral of 1 over square root of a squared minus x squared, all with respect to dx. Your integral here is going to be sine inverse of x over a plus your constant of integration. You have an integral 1 over square root of a squared minus x squared with respect to dx. Your integral is going to be sine inverse of x over a plus c. And the last one we're going to look at, which is a very crucial integral, is this. Is the integral of the form f prime of x over f of x with respect to dx. What does this mean? This means that this is that kind of integration where if you differentiate the denominator of that integral and you get the numerator, the integration of this will be ln f of x plus c. Will be ln of absolute value f of x plus c. Now let me give an example of something like this. Now if I have an integral of 2x over x squared, let me just put it like this, or let me put it as, okay, yeah, we have something like this. Now simply our answer will simply be integral of this will simply be ln x squared plus c, because if you differentiate x squared, you're going to get 2x. So if you differentiate the denominator, you're going to get the numerator. So it will just be ln of this. Okay, so that's the integral of this form. You differentiate, if you differentiate the denominator and you get the numerator, your integral will simply be ln f of x plus c. Okay, so these are the basic formulas that you need to know when it comes to integration. So if you know all this, I guarantee you that you are going to have a solid foundation on integrations. You'll be able to solve problems, different problems and different questions. Now in our next video, I'll be solving more questions on integration. Make sure you anticipate that video. Thank you. Until next time.